This is our final example for the day in 3.5 day 1. It's also our second example having to do with the inverse properties in order to solve exponential or log equations. Now this one is an exponential, so we're going to be introducing a log at some point here, but we've got a few steps to work with before that happens. One thing I just want you to recognize here, if you maybe look back in your notes for this chapter, this is a logistic function. So this should be kind of familiar. You should look at that and say, oh, feels like we've done that before, because we have. This represents a logistic function, and so this is a different way now that you can solve logistic functions. Before we were just using graphs. Here we're going to use the algebraic method of using the inverse properties. But we need to get rid of fractions first. So we're going to multiply both sides by that denominator. We want to get rid of the fractions. So 1 plus 95 e to the negative 0.6x. We're going to multiply both sides by that. Which of course will cancel out the denominator over here, leaving us with 400. And then over on the right hand side, we want to just distribute this to those two. So we're going to have 150 plus 14,250 e to the negative 0.6x. Okay. Moving along from there, we can subtract the 150. So that means 250 equals what we have left over here. Then we want to divide by 14,250 from over here. Now you can simplify if you want, but it's really not going to make that much difference in the next step. I'm just going to put them like that and say that this is e to the negative 0.6x over here. And the reason it doesn't really matter is because the next step is just going to be a calculator step anyway. We're going to, because this has a base of e, we're going to introduce on both sides of the equation ln. That will get rid of this e. We just have to do it over here as a consequence. But we have ln on both sides. That's going to mean that the right-hand side of the equation, the ln and the e cancel out. You just get negative 0.6x. On this side, we have to let the calculator help us out a little bit here. So we've got ln of 250 divided by 14250. So that gives us about negative 4.043. All right, so negative 4.043 equals negative 0.6x. And so finally now we can divide by this negative 0.6. And we'll get something for x. It'll just be an approximation. So I'll go back here, divide this by negative 0.6. And we get about 6.74 is probably close enough here, about 6.74 for x in this case. So we solve this one algebraically, starting up here with this logistic. And the key thing here is to get rid of the fractions, introduce the ln, and then eventually get x solved for what we see right here. Like before, it's always a good idea to plug it back into the original to see if it works. There aren't going to be any troubles with this one, so 6.74 is going to be our answer for this equation.